I wanted to introduce you today to something called measures of spread. So we have looked at measures of center, mean, median, and mode, but that's not always enough. A lot of times we're interested in knowing, is the data centered towards the middle where the mean is, or is it more spread out? And so I'm going to look at a couple of examples here with you, starting with a company. Two companies we're going to compare. Suppose you're applying for a job and you're looking at their hourly wages. And suppose you're given the average hourly wage for each, and they turn out to be the same, $20 per hour. And you might think, well, so then it doesn't really matter which of the companies I would choose. But I would say, yeah, be a little careful there. These are apparently small companies. Company A, with 6 people, have their pay is pretty close to each other. We have the lowest pay is $19 an hour, and the highest is $21 an hour. So not a big difference. Compare that to Company B. Much more spread out. The lowest paying person makes $15 an hour, and the highest $26. Much bigger range. So you probably have to look in a little further into what would you get paid if you started here. So again, just knowing the mean and median is not enough. You need to know a little bit more usually. So I said the range is different. So the word range in statistics means the maximum value minus the minimum value. And so you subtract them. So the range for the first company would be 21, that's the highest, minus 19, which is the lowest, and so that's 2. There's only a $2 difference. Compare that to Company B, which has the highest at 26 and the lowest at 15, so that's an $11 difference. So right there, that's one measurement that we can use as the range. You subtract the highest and the lowest and see how widely spread are they. It's an easy way to calculate spread, but it's not necessarily the best because we're only using 2 data points out of a sometimes big data set, and it's the most extreme values at that. And so there are better ways. Let me show you a different example, something that I have to deal with frequently. I'm looking at exam scores for different classes, and sometimes I compare them and I might see, oh, they have the same mean or median too, perhaps. That does not mean that these are very similar classes to teach. Look at class 1. We have a mean at 75, and most students are scoring close to this number. Very few score really high or really low. Compare that to class number 2. We also have the same mean, and very few people actually score around 75. A lot of students score really high, but a lot of students also score really low. And so the second class is a much harder class to teach, right? I have students that feel like this is a challenging class and they need more support from me. On the other hand, I also have students that might find this class to be too easy, so I need to challenge them more. So 2 very different classes in how I would teach them. And so again, mean is not enough. If we looked at just the range right now, it would actually be the same for each. They both have a maximum value of 100 and minimum value of 50. So the range would be 50 from both. But again, that's not enough information because we can see that they look very, very different. And so a better way to calculate the spread is called standard deviation. And that's what we're going to learn next, which takes into account every single data value in each of these. But that's coming up next. Thanks for watching.